So we're going to start day 4 of adding and subtracting rational expressions. Yesterday we just looked at binomials, binomials and monomials. Today we're going to look at how do we go about adding and subtracting if we have binomials and trinomials. So we're going to have to go back to some of our factoring skills that you've obtained throughout the year to kind of help us with today. Process is going to be the same. Like the last few days, you have to have common denominators in order to add or subtract. So we're going to look at making common denominators, whether it's in factored form or not. Looking at those different things today. So when adding and subtracting rational expressions with binomials and trinomials, first thing you always have to look for is you have to look to factor first. Has to be the first thing that you do. When binomials and trinomials are in the denominator, you need to factor first if they can be factored. If they're already factored for you, you really don't have to worry about it. Once you have that done, then you can try to get the denominators the same. Now, this says an incorrect way and a correct way. I have no real reason why I would ever want to show you an incorrect way to do this, because it would just confuse you. We're just going to do it kind of the correct way. So if we look at this one, it kind of resembles one that we had yesterday. We've got a binomial in both of our denominators. We look to see if everything's factored. If we look at each of these terms, that's already factored. There's nothing that can be factored there. That's already factored. There's nothing that can be factored there. So now we're just going to treat this like we did yesterday. We're going to start on the left-hand side and write down the x plus 5. There's nothing else there. We go to the second term. We put our x minus 3. That's going to be our common denominator. Again, this is a lot like what we did yesterday. And when they're already in that form, we're good to go. So the second thing then we did yesterday was we compared denominators. So we compared this with this. We said, okay, what's not there? I've got x plus 5 and x minus 3 is my new denominator. And in the top, I only have x plus 5. So that means I need to multiply this one by x minus 3. Well, no, they're switched order. That's okay. But what you do to the denominator, you have to do the same thing to the numerator. Distribute. 2x times x is 2x squared. Minus 3 times 2x is 6x. So those two fractions or ratios are equivalent to each other. Now we go to the second one. Second term, we've got x minus 3, but the new denominator is x plus 5 and x minus 3. So that means I need to multiply this one by x plus 5 in both the numerator and the denominator. Now what's here is the same thing as what's there. These two things now, though they're reversed order, have exactly the same binomials in them. Again, we distribute. 3 times x is 3x. 3 times 5 is 15. We've got all our equivalent fractions written down. Now we can go to the last step. The denominator stays exactly the same. X plus 5 and x minus 3. We perform the operations in the numerator. 2x squared, there's no other x squareds in there. Just 2x squared. We've got negative 6x plus 3x. So that's negative 3x. And we only have plus 15. There's our solution. Whole big thing about this, and we talked about it a lot yesterday, is making sure you get that common denominator. Once you get that common denominator, get your equivalent ratios. Leave the denominator the same, perform the operation on the top. Questions with the first one? Just like yesterday, right? Where they get a little bit more difficult then is obviously when we start looking at something like this. So now we've got 2x as our numerator, and x squared plus 3x minus 40 as our denominator, plus 3 over 2x plus 16. So our first step has to be to factor first. Always factor first. And you look over each term. Can 2x be factored? No, it can't be factored. X squared plus 3x minus 40. It's a trinomial. So because it's a trinomial, that means I'm going to try the x method. So over on the side, my c value is in the numerator. I'm sorry, the number on top. 3 is the number on the bottom. So I need two factors of 40 that multiply. Obviously, they're factors, so they multiply to be negative 40. So one's negative and one's positive. They have to add up to 3. 8 and 5. So the 8 is going to be positive. The 5 is going to be negative. Negative 5 plus times 8 is negative 40. Negative 5 plus 8 is 3. So this factors to x minus 5, x plus 8. Now I'm going to take this, and I'm just going to kind of cross that out because I don't need it anymore. I'm going to kind of ignore it. We look at our other pieces. The 3, that's already factored. 2x plus 16, 2 terms. Look for a greatest common factor. Common factor is, 2. So if I take 2 out of 2x, I'm left with x plus 8. Now I start on the left-hand side. We've got everything factored. Now we start on the left-hand side and we just start writing. So we've got x minus 5. We've got x plus 8. I go to my second term. There's a 2 there. Now, just for ease of purposes, I'm going to put the 2 right there. And then I've got another x plus 8. So do I have to put that x plus 8 again? Nope. So my least common denominator, or my common denominator, is 2 times x minus 5 and x plus 8. Now we have that part set. We go to the next step. I highlight that denominator, and now I just highlight what I've already got up there. The only thing not highlighted is the 2. Since the 2 isn't highlighted, that means I need to take both the numerator and the denominator times 2. 2 times 2x is 4x. Again, if you don't have a highlighter, which you don't, I can just kind of put a light X through what I have. I have that and I have that. What I don't have is the x plus 8. Well, I'm sorry, the x, I crossed out the wrong things. My bad. I have the 2 and I have the x plus 8. So I don't have the x minus 5. So that means I need to take the numerator and the denominator by x minus 5. Now what I have here is exactly the same thing as I'd have down there. 3 times x minus 5 is, highlighter not need to be used, 3x minus 15. Distribute. We're ready to finish it off. Our common denominator is 2 times x minus 5 times x plus 8. 3x plus 4x is 7x minus 15 or plus minus 15, whatever, minus 15. And we're done. What did I do, Red? Why did I write 4? Didn't I say 7 out loud? I thought I said 7. 7 and 4s, they look a lot alike. What can you do? It correctly? Nah, what'd be the fun of that? Okay. Factor first, factor first, factor first, factor first, factor first. Always factor first. Any questions with that one? Everybody have enough time to write it down? All right, so for the next one. Three x plus 1 over 5x squared plus 15x minus 8 over 5x. Can 3x plus 1 be factored? I don't think so. What about 5x squared plus 15x? Two terms. What's the greatest common factor for the numbers 5 and 15? 5. Common factor for x squared and x? X. So if I take 5x squared divided by 5x, what am I left with? X plus 3. 15x divided by 5x is 3. Okay, so I'm going to go ahead and just kind of cross that out. I don't need it anymore. I look at the 8 and the 5x. They can't be factored anymore. 8 and 5 don't reduce, so we're good to go. Start on the left-hand side with a writing utensil. Start on the left-hand side gives me 5x times x plus 3. If I go to the next one, I've got a 5x. I don't need to redo it again. I've already done it once. So 5x times x plus 3. I highlight and highlight everything I have. I got everything. So I don't need to do anything to the first one. So I can just put 3x plus 1. I highlight what I have. I have the 5x and the 5x. The x plus 3 hasn't been highlighted, so that means I need it. If I compare now, everything's highlighted. If you can circle, you can do whatever you want. 8 times x is 8x. 8 times 3 is 24. Perform the operation. 3x minus 8x. 3 minus 8 is negative 5 x's. Now the one everybody messes up. 1 minus 24. 1 minus 24 is negative 23. All over 5x times x plus 3. Anybody guess what the common error is now? Are we done, or can this be reduced further? Say we're done. We're done. Because there's a minus symbol there, this 5x and this 5x, they can't be crossed out because that's being subtracted. Okay? Questions with that one? Are we ready to try one? Well, we will. Let's go 3x over x squared plus 2x plus 1 minus 2x minus 3 times over x plus 1. Let's go ahead and try this one. factor first? Does 3x factor? That doesn't. But does the denominator factor? I think so. It's a trinomial, so x method. 1 and 2, so 1 and 1. So this becomes x plus 1 times x plus 1. So that's gone. So what's my common denominator going to be? X plus 1. I have to do another x plus 1 because there's 2 in this one. My common denominator has to have 2. Do I have to put a third? No, because I've already got 1 there. So we're good to go. So this is going to be x plus 1 and x plus 1. So we've got our common denominator and should go ahead and finish it off. Give you about 2 minutes. Oh, you're going to have to pour it. That was me. Circle what I have, since you don't have access to a highlighter. Do I have to add anything into the first one? Yes or no? Nope, so I can just write the 3x. Second one, I have this one, so I've got that one, but I don't have the second. So that means I need to multiply by x plus 1. Both the numerator and the denominator. Now they're the same. So we've got to FOIL this. 2x times x is 2x squared. 2x times 1 is plus 2x. So first outside, the inside. Negative 3 times x is negative 3x. And then negative 3 times 1 is minus 3. So I'm just going to look at the numerator. So that's 3x minus 2x squared minus x minus 3. If I kind of fix that part, it's minus x. So now I've got 3x minus another x. So minus a minus is a plus. So that gives me 4 x's. I've got negative 2x squared. And a minus is a plus, so plus 3. We have to be careful with this minus symbol. It has to be distributed to each and every single one of them. That's our numerator. Our denominator was x plus 1 and x plus 1. And there's your solution. Okay. Key to all of this today. Common denominators. If you have trinomials in your denominator, factor those using the x method. If you've got a binomial, 2 terms in your denominator, look to take out a GCF. Factor first, find your common denominators, compare your denominators. What's not there, make sure you multiply the numerator by. Do that for both of your terms. And then combine like terms. Assignment for today is inside of Schoology. I think there's probably somewhere in the neighborhood of 12-ish questions. Okay, you've got about 30 minutes. Not quite 30 minutes. Should give you plenty of time to do that as you're going around. If you have questions, please make sure that you ask.